Jai Hind students, welcome to my YouTube channel. Today we'll be discussing a very interesting and important topic of inertia. Now look students, inertia. This term was first formulated by Galileo, right? And this is actually derived from the Latin word iners, I-N-E-R-S, iners. It's a Latin word which means that lazy. Iners means lazy or idle. Iners means lazy or idle, means unresponsive. So let's now discuss inertia. What does it actually means in physics? Now students, you must have seen around yourself that a body which is at rest, like a sofa set or a chair which is lying at rest, it will tend to remain lying at rest unless some external unbalanced forces applied over it, isn't it? Similarly, if a body is in uniform motion along a straight line and assume that there is no friction, in that case, the body will keep on moving with the same speed and along the same straight line indefinitely. It will never stop in case friction is absent. So what I mean to say is that a body tends to remain in its state of uniform motion along a straight line unless it is acted upon by some external unbalanced force. Similarly students, if a body moves in a particular direction, then it will keep on moving along that direction only. What I mean to say is that without applying any external unbalanced force, a body do not change, or rather it cannot change its direction of motion by itself. So in that sense, a body is quite lazy. Every body in the universe is quite lazy, or they do not have any ability to change its state of rest or of uniform motion along a straight line by itself. So what I mean to say is that a body cannot by itself change its state from rest to motion, or from motion to rest, or change its direction of motion. In the previous lecture students, we have discussed the effect of force. Now when a force is applied to a body, I am talking about unbalanced force. Now when a force is applied on a body, then if the body is at rest, then it might get changed into motion. It will change its state from rest to motion. It might change, right? Similarly, if a body is in motion, then by applying retarding force, braking force, the body will come to rest. And if force is acting perpendicular to the direction of motion, then also we have discussed, in that case the body tends to follow a circular path, isn't it? And in the absence of any force, what happens is, if a body is following a curved path, then what happens is, in the absence of force, it will tend to move tangentially, in the absence of any force. So what I mean to say is that it is only the force under the influence of which a body can change its state of rest or of uniform motion. It is only and only under the influence of unbalanced force, right? So what does inertia means basically? It is an inherent property. It is an inherent property. Inherent property of all the bodies. It's a fundamental property of all the material bodies. Students, as you are aware, all the bodies are made up of matter, isn't it? So, it is an inherent property of all the bodies by virtue of which a body, if it is at rest, it will tend to remain at rest. If a body is in uniform motion along a straight line, it will tend to remain in uniform motion along a straight line. So this inherent property of a body, by virtue of which a body cannot by its own change its state of rest or of uniform motion, is known as inertia. So inertia, as I have stated, it's a term which denotes the unresponsive or laziness of a body, isn't it? A body can't by itself change its state. That's inertia. Now, we are very much aware. Suppose two bodies, one of lighter mass and one of heavier mass. This is M2. Both are at rest. Both are at rest. Obviously, in the absence of any external unbalanced force, both these bodies A and B will tend to remain at rest only, isn't it? Now, if I intend or if I wish to change the state of these two bodies from rest to motion, then what happens is I need to apply some external unbalanced force. It is common sense, students, that in the case of lighter body, small effort or small force will be required to change its state from rest to motion. While in the case of a heavier body, much larger effort will be required to change its state from rest to motion. So what I mean to say is that this body, which is heavier one, which has large mass or large amount of matter contained in it, that will provide more resistance, more opposition towards any change in its state. Isn't it, students? So the lighter body, which is having small matter, small amount of matter, this will also offer resistance towards the change in its state. But the resistance offered by a lighter body is much lesser as compared to the resistance offered by a heavier body towards any change in its state. So what do you conclude from this? It is the mass of the body that gives the measure of the inertness of a body. Mark my words, student, this is very, very important. Mass gives the measurement of the inertness of a body. The greater the mass of the body, the more will be its inertness. The smaller the mass of the body, the smaller will be the resistance, or smaller will be the inertness of the body. So mass is the physical quantity that gives the measure of the inertness of a body. Clear, students? So, heavy body, if we intend to change its state from rest to motion, or if we intend to change the state of a heavy body from motion to rest, then a large force is to be applied. And for lighter body, smaller force is required. Isn't it? So it clearly suggests that it is the amount of matter which is contained in the body that gives the measure of inertness of the body. Right? So inertia may be also defined as the resistance or the opposition which a body offers towards any change in its state of rest or of uniform motion. So again I repeat, students, inertia is an inherent property of a body by virtue of which it resists any change in its state of rest or of uniform motion along a straight line. Or in other words, it is the inability of a body to change its state of rest or uniform motion by itself. In more simpler words, a body at its own cannot change its state of rest or of uniform motion along a straight line. So that's inertia. Now, talking about the types of inertia, students, inertia can be broadly classified into three types. One is the inertia of rest. First is the inertia of rest. Second is the inertia of motion. And third one which we will discuss is the inertia of direction. So, let's start with inertia of rest. Let's start with the first topic, inertia of rest. Students, as the term suggests, inertia of rest is the property of a body by virtue of which a body tends to remain in its state of rest unless it is acted upon by some external unbalanced force. Isn't it? So a body which is at rest will remain at rest unless it is compelled to change its state by some external unbalanced force. There are various examples, there are numerous examples which is related to the concept of inertia of rest. Like, students, take the simple example of a sofa lying on a floor, it will keep lying on the floor unless we apply some force so as to change its state from rest to motion. Right? That's a simplest example. Second example is, if you shake the branches of a tree, then the mango will fall down. Why it happens? It is because of inertia of the rest. Because students, on shaking the branch of a tree, what happens is, due to the inertia of rest, the mango, it will remain at rest, while the branch of the tree will move. So as a result, due to the watering strain, the fruit will fall down. So that's the concept of inertia of rest, right? There are some other examples as well, which I will illustrate with the help of this small clipping. So do watch this clipping and I'll illustrate each and every example. These all are related to the concept of inertia of rest.
Let us consider a person to be standing inside the bus, which is at rest. Now, as the bus starts moving, the lower part of the body of the person, it comes in motion. But because of inertia of rest, the upper part tends to be at rest. Hence, the person falls backwards. In this case also, it is due to the inertia of rest that the ball falls inside the beaker. These are some simple activities and experiments which suggest the very fact that it is the inherent property of a body by virtue of which a body tends to remain in its state of rest unless it is acted upon by some external unbalanced force. A body can change its state of rest only and only under the influence of some external unbalanced force.
Okay, second is students, inertia of motion, right? So it is the inherent property of a body by virtue of which a body tends to remain in its uniform motion along a straight line unless it is acted upon by some external unbalanced force. So that is inertia of motion. I'll give you a small illustration. Suppose this is a smooth horizontal surface. It's a smooth surface. It is a smooth surface. Smooth surface means we are considering force of friction to be zero. Force of friction to be zero. It's a smooth surface. And suppose a ball is moving along a straight path with uniform speed of suppose 2 meters per second. A ball is moving along a straight path with a speed of 2 meters per second, right? This is the uniform motion. The body is in suppose uniform motion. So in this case, the body will keep on moving along the same straight path. Initially, it is having a velocity of 2 meters per second. After 10 seconds or after 20 seconds, it will have the same velocity. That is, its magnitude as well as direction will remain same. Only when force of friction is considered to be absent. So in the absence of any external force, if this body is initially in motion, then the body will remain in its state of uniform motion along a straight line. Remember, no force is acting. So the speed of this body will not change. The direction of motion of the body will also not change. Therefore, the body will keep on moving along the same straight path with the same speed. Therefore, inertia of motion is the property by virtue of which a body tends to remain in its state of uniform motion along a straight line unless it is compelled to change its state by some external unbalanced force, right? This is an ideal scenario where we have considered the force of friction to be absent. But normally, the surfaces, when the two surfaces are rubbed against each other, or one body tends to slide or roll or move against the surface of some other body, some force of friction does always exist. So in our daily life, what we observe is when our body is moving, then after some time, after covering some distance, the body eventually comes to rest. That's because of frictional force between the two surfaces in contact. So under the influence of that frictional force, the body is changing its state from motion to rest. But in case frictional force is considered to be absent in the ideal scenario, then if a body is moving, it will keep on moving along the same straight path without changing its speed. Isn't it? So neither its direction of motion changes nor its speed increases or decreases. So students, a very, very important conclusion, it's a very important thing. For a body to move in uniform motion, no force is required. I repeat, for a body to move in uniform motion, that is, for a body to move along a straight path with constant speed, or you can say constant velocity, no force is required. So, suppose it's a conceptual question, it might be asked in your exams. Let us consider a body to be moving with uniform velocity of 10 meters per second. Uniform velocity. Uniform velocity. Right? Velocity, as you are aware, students, it's a vector quantity having both magnitude as well as direction. If I say uniform velocity, what does it suggest is the magnitude of the velocity, which is the speed, that is constant, as well as the direction of motion of the body is also constant. So uniform velocity means neither the magnitude nor the direction of the velocity is changing. Right? So if a body is in uniform motion, which means that it possesses uniform velocity, then what is the net force acting on this body? So in this case, the net force acting on the body would be 0. Please do remember, if a body is in motion, it doesn't mean that force is acting on it. If a body is in non-uniform motion, then some external force, unbalanced force must be acting on the body. But if the body is in uniform motion, that is, if the body is moving along a straight path with constant speed, then no net force is acting on it. And in that case, the body will tend to keep moving along the same straight path with the same speed in the absence of any external unbalanced force. So this inherent property of the body is known as inertia of motion. Again, there are various examples of inertia of motion, which again I'll explain with the help of this small but very interesting clipping. Right? Do observe it.
Let us consider a bus suddenly stops. Then the person in the bus will experience a force in the forward direction. It is because the lower part of the body of the passenger, which is in contact with the bus, comes to rest. But because of inertia of motion, the upper part of the body tends to keep on moving. As a result of it, the passenger experiences a force in the forward direction because of the imbalance in his body. So this is due to inertia of motion. Similarly, when a running horse suddenly stops, the rider falls forwards because the lower part of the body of the rider comes to rest, but because of inertia, the upper part of the body tends to keep on moving. As a result of it, the rider falls.
The third one is the inertia of direction. Now, inertia of direction is the inherent property of a body by virtue of which a body tends to resist any change in its direction of motion. Or in other words, it's the property of a body by virtue of which a body tends to move along its original direction of motion, unless it is compelled to change its direction by some external unbalanced force. Right, students? So here also I would like to give you an illustration. I have told you, whenever a body is moving along a circular path or a curved path, then the direction of motion of the body is always given by drawing a tangent at that particular point. Like, this is a circular path, and suppose the body starts from this particular point, and this is the center, and it is moving in the anti-clockwise direction. It's moving in the anti-clockwise direction. So at any instant, its directional motion is given by drawing a tangent. At any instant, its directional motion is given by drawing a tangent. Tangent means a line at a point on the surface which is perpendicular to the radius. That's tangent. So the point is, whenever a body is moving along a circular or a curved path, then the directional motion of the body changes continuously, because its directional motion at a point is given by drawing a tangent at that particular point. And I've told you, when a body follows a curved or a circular track, then its directional motion changes continuously. Now direction changes means velocity changes. Velocity changes means it's the case of acceleration. Acceleration can be produced only under the influence of some force. So a body is able to move along a circular path only under the influence of some external unbalanced force. Now imagine if that external unbalanced force ceases to act. I mean, if that external unbalanced force vanishes or stops acting, then what will happen? In that case, what will happen is, suppose at this point, at this juncture, at t equals to t, this external unbalanced force which is making the body to move along a circular path suddenly disappears, suddenly stops. Then what will happen? Then the body won't be able to complete the circular path. Instead, at the instant when the force becomes zero, thereafter the body will fly off tangentially. It will fly off along this direction, because now it will tend to move along its original direction of motion, because there is no force to change its direction. A body by itself cannot change its direction of motion. It is only under the influence of force that the body can change its direction. Have I made myself clear, students? So the inability of a body to change its direction of motion by itself is known as inertia of direction. And here I must remind you, we have discussed it in the topic of uniform circular motion, that when a body moves along a circular path, then the force involved, or the force which makes the body to move along a circular path, is known as centripetal force, and the acceleration is known as centripetal acceleration. And that force always acts perpendicular to the direction of motion of the body. This is the direction of motion of the body, and this is the force which is acting perpendicular. As long as this centripetal force or this force exists, the body will keep on moving along the circular path. It will keep on changing its direction of motion continuously under the influence of this external unbalanced force. But as soon as this force becomes zero, the body, instead of following a circular path, it will simply fly off tangentially. So that's the concept of inertia of direction. Again, I'll show you a short clipping along with some examples will be illustrated which belongs to this category, inertia of direction. Right?
Consider a bus to be moving and taking a sharp turn towards right. The person in the bus will experience a force towards left. In this case, the body cannot by itself change its direction. It is only under the influence of external force that it is changing its direction continuously. The sparks coming out of a grinding stone are tangential to the rotating stone. It is due to directional inertia or inertia of direction. Once the sparks are produced, no external force acts on the sparks, and in the absence of external force, their direction of motion cannot change. The sparks so produced follow paths tangential to the grinding stone.
So students, we have discussed the concept of inertia. Then we have discussed the types of inertia, inertia of rest, inertia of motion, and then we have discussed inertia of direction along with several examples. I hope you have enjoyed the clippings, right? So let us recapitulate all the important things which we have discussed in this particular session. So students, inertia is the inherent property of a body by virtue of which a body tends to oppose, tends to resist any change in its state of rest or of uniform motion. Or a body cannot by itself change its state of rest or motion, isn't it? It is only under the influence of some external unbalanced force that a body can change its state from rest to motion or from motion to rest, or the body can change its direction only under the influence of some external unbalanced force. So this property, this inherent property of a body is known as inertia. And mass is the physical quantity which determines or which gives the measure of inertness of a body. So students, this concept of inertia was formulated by Galileo, and it is only on this concept of inertia that Newton's first law of motion is based upon. And this is the reason why Newton's first law of motion is also known as Galileo's law of inertia. First law of motion is entirely the law of inertia. Whatever we have discussed in the concept of inertia along with the types, it is the same as that of Newton's first law of motion. So students, what will be the statement of Newton's first law of motion? What we have studied throughout this lecture? Every body in this universe tends to remain in its state of rest or uniform motion along a straight line unless it is acted upon by some external unbalanced force. That is what we have studied in this topic of inertia, and this is, student, known as Newton's first law of motion, which is also known as Galileo's law of inertia. Right, students? So for this session, I think these topics are more than sufficient. Do enjoy the clippings and do understand the concepts. These are some very important topics which we are dealing with. Right? So we'll continue in the next lecture then. Thank you, and do take very good care of yourself.